Hi, I'm happy to be here today. I'm going to be talking about how we can use Data Prepper to get data into OpenSearch in a durable way and improve the performance of our cluster. I'm David Venable. I'm a senior software engineer at Amazon Web Services. I'm a maintainer on the open source Data Prepper project that we'll be talking about. I also work on Amazon OpenSearch ingestion, which provides a serverless form of this to Amazon OpenSearch clusters. Today, we're going to be talking about a few things. First, I'm going to give an overview of what Data Prepper is. I'm going to talk about our two general types of sources, because those are going to relate to how we provide our solutions for durability. So then we'll dive into that and get into some of the details. I'll talk about how you can handle failures that happen in your pipeline, and how you can use Data Prepper to help with the overall performance of your OpenSearch cluster. Now, first I want to explain where Data Prepper fits in. So we can see that the core offering of the OpenSearch platform is OpenSearch Core. This is the set of REST APIs that provide distributed Lucene. I think everyone's really familiar with this part. We also, of course, have OpenSearch dashboards, the web UI to visualize that data. And then the third pillar of our platform is Data Prepper. This is how you can ingest data into OpenSearch Core so that you can query it later or visualize it, run your analytics. The key concept within Data Prepper is that of a pipeline. So you, as the Data Prepper user, will define your pipeline. It defines a set of sources that you're going to read data from, some external bit of data. You put that into a buffer, and then we're going to run a set of processors that you define over that. You use these processors to prepare your data. You can perform enrichments, mutations, whatever you want to do before putting it into your OpenSearch cluster. Then Data Prepper has a sync concept that will push it out to the external sync itself. All of these components are pluggable, so you can write your own. You can contribute it back to the community if you want. Say if you wanted to write a new source for a popular product, you could contribute that back. Or if you have custom processors you want to write, you can also write your own custom processors and keep those internal. Now, our main sync is, of course, OpenSearch. That's the main goal that we have. Let's get data into OpenSearch. But we also support syncs that help contribute towards a lot of common OpenSearch workloads. For example, we can send data to Amazon S3 as well. A lot of people ask for that so that they can have long-term retention. You can also perhaps send some data to OpenSearch, and then all of it to S3 so that you know you have it stored. Now I'm going to talk about the two types of sources that we provide, or that we support. So first are push-based sources. In this case, Data Prepper runs as some sort of server, and you send data to it over HTTP or perhaps gRPC. Once Data Prepper receives it, it puts it in the buffer and sends it down to the sync. Now, here are some examples of the push-based sources we support. One, we have an HTTP source. You can use this to get log data into Data Prepper, for example, and then down to OpenSearch. You can use the FluentBit collector or the FluentD collector. You can use either of those and then send your data. We also support OpenTelemetry sources. We have 3 of those. There's trace, metrics, and logs. I think we've heard a number of talks today about OpenTelemetry, and so this is another option you can use when collecting data with the OpenTelemetry collector. Tomorrow I'm going to be giving a talk with Yannick Brand from SAP. They are actually using Data Prepper and OpenSearch to create a cloud logging solution. So I encourage you all to come to that, and I'll link to that at the end. Now, we also support pull-based sources. In this case, you have some external server or perhaps a resource, and then Data Prepper is going to go out there. So for example, Data Prepper might make a request to a server, and then data flow starts coming in. That server is now sending the data to Data Prepper, and then we push it down all the way, just like we would with the push-based sources. We have a few of these. S3 source is one of them. That one supports getting data from Amazon S3. You can do this using SQS to kind of trigger Data Prepper to know which messages to read, or it can scan a bucket. We also have a Kafka source. So if you're putting data into a Kafka topic, you can connect Data Prepper to that and read from Kafka. We have an OpenSearch source that was built for migrations to help you migrate from older versions of OpenSearch to newer. And then we also have a couple of zero ETL type of sources, DynamoDB, and we have an upcoming Amazon Document DB source as well. All right, now that we know the two basic types, I'm going to talk about how we offer durability for users when they have those sources. First, let's talk about those pull-based sources. With those pull-based sources, we offer a concept called end-to-end acknowledgements. So going back to what I showed earlier, Data Prepper reaches out to retrieve data, and then data starts flowing in. As that data comes through, we send it down to the sink. And you can imagine if you have some failure, perhaps your node shuts down, or you're unable to communicate with the sink, well, you don't want to lose the data that was originally on your source. And so with end-to-end acknowledgements, what we do is only after sending the data to the sinks, we send internally a message back to our source, and then that source is able to reach back out and acknowledge this with the external source. So for example, with Amazon S3 that I mentioned earlier, if you have an SQS queue, it's at this point that we acknowledge that message on the queue so that it can be removed and not reread. Or if you have a Kafka source, this is where you run your Kafka commit. Using end-to-end acknowledgements with Data Prepper is really easy because the maintainers did the work for you. And so all you have to do when using one of these sources is set this flag, acknowledgements to true. And once you do that, Data Prepper's internal end-to-end acknowledgements will turn on for you. Also, if you happen to be using the S3 source, we recommend this visibility duplication protection flag. We found that if you use this, this helps you not have to tune your visibility timeout and prevent duplicate messages from coming through. Now I'm going to talk about some of Data Prepper's buffering concepts. Our first buffer is an in-memory buffer. This buffer is the default, and it's built around speed. It goes really fast. And so you can use this to get data in really fast. It also works for a lot of situations. So for example, with those pull-based sources, we put it in an in-memory buffer, and it's going to be fine because we haven't acknowledged it on the source yet. There's no need to restore the data here. It also works for a lot of users, even with analytics pipelines like log analytics or OpenTelemetry. Some people are fine with losing a little bit of data here and there. But if you really want to be sure you have your data persisted, Data Prepper also offers a concept called the Kafka buffer. This is something that the maintainers added to help provide persistence of data, especially with those push-based sources, so that you can send messages from an HTTP client and be sure it's stored before it reaches your sink. I'm going to talk about how that works real quick. So let's say we have an HTTP client. It's sending data to the source. It comes into the buffer, and what the buffer is really doing is it's writing that data to a Kafka topic. Now that the data is in Kafka, we have it persisted, and we know that we can pull it up later, even if the node goes down. And so this is the point at which Data Prepper responds back to the client with that 200 OK, saying, yes, you client don't have to worry about this data anymore. We have it. Separately, in another thread, Data Prepper is also running as a Kafka consumer. And as this Kafka consumer, it's reading from the topic, collecting the data, and then sending it through your processor chain that you define, and ultimately out to your sink. Now, I mentioned end-to-end acknowledgements earlier, and we use that concept here in the buffer as well. Only after it's read into OpenSearch do we send that acknowledgement back to the Kafka buffer, and then we're able to make the commit to the Kafka topic. And so now we're not going to reread the message. We know it's in OpenSearch, so it has its persistence there, and we can remove it from Kafka. I'm going to talk a little bit about an upcoming concept that we're working on with the idea of an S3 buffer. We're actually using this with our document DB source. Basically, what we do is we have a pipeline transformation that takes a pipeline, splits it into two, where you have an S3 sync right into an S3 bucket, and then S3 is reading from there. We're looking to generalize this more so that you can use it with any source. And then also, anytime you have a data prepper S3 sync and S3 source, we could probably make this kind of concept without having to rewrite a new buffer type. I want to talk about handling failure situations. OK, so we know that sometimes data doesn't make it to the sink, and no matter what your best intentions, it's not going to get there. This could happen, for example, if your cluster is overwhelmed, or perhaps you have a write lock on it. We also see this happening with mapping failures. So maybe you have some new data coming in, and there's a change in the mappings that doesn't allow it to work, or maybe you have conflicts. We added a dead letter queue concept, or DLQ, to Data Prepper to help you with these types of situations. Right now we have two. We have an S3 DLQ and a file-based DLQ. The S3 will write to an S3 DLQ bucket that you define. Or you can use the file-based one that writes to a local file. That can work really well if you have EC2 with EBS, for instance, and know that you have the data there. Concept here is pretty straightforward. You try to write, you're unable to. I should mention Data Prepper does retry on certain types of failures so that it doesn't just give one try and then fail. It will do that if it's a mapping error, for example, but on most kind of 500 type of errors, it's going to retry for a little bit. After it gives up, it writes to the DLQ. And so now you have that data persisted somewhere. And so that you can come back, you can analyze what happened. We also include the failure message in the DLQ. So you can look at it, see what happened, and then take care of it. Maybe you got to clear up some space on your cluster. Or again, if you have a mapping error, maybe you can find that there's a new processor you can add. And then now that you've figured out your problem, you can create a DLQ to replay the data. Again, this is just any other pipeline, and so you can add processors. So for example, if you did find a mapping error, you can have a processor that will change the data, again, to what you need before you put it into OpenSearch. Enabling this is pretty easy. So this is an example of enabling the DLQ for S3. You just need to define a bucket, and you can include a key path prefix if you want. Right now, the DLQ is tied to the OpenSearch sync. And again, it only supports two sources. There's S3 and the file base. One of the things we're looking at doing, we have an open issue for in GitHub, is creating the concept of a pipeline DLQ. With this concept, if you have a failure, say, in the processors and you don't want to push the data any further, you push it on to another pipeline that's specifically set up to be a DLQ pipeline, and then that'll write out to Amazon S3. Or, once we have the pipeline DLQ, it could write to any of our S3 syncs. So for example, we have that Kafka sync. You could write to a Kafka topic instead of putting it in Amazon S3. Again, this is something that we're looking into doing, but it's not available yet. All right, I want to talk some about how Data Prepper can help you with the performance of your cluster. First, you put Data Prepper in front of OpenSearch. And so it's going to add the first layer of buffering. And in this way, even if you have many, many clients sitting around, all those clients are going to send their data to Data Prepper first. This way, you can buffer the data and create large bulk requests to go into OpenSearch. This alone should be able to help in a lot of situations so that your clients aren't sending small bulk requests. Now, I'll explain this briefly. Data Prepper is receiving events from different clients. So maybe this is a batch of events from your first client. And then you get another client and then a third. We're going to buffer this up and then push it out as a group to OpenSearch. By default, Data Prepper provides a bulk size target of 5 megabytes. We've done some performance analysis on a number of pipelines. We actually find that 20 is a bit better of a number. So if you are using it, I encourage you to work with configuring your bulk size. Maybe increase to 20 and see how that works for you. I don't show this here, but you can also increase your batch size. That'll send more data in a batch. And we've also found that increasing that improves the performance of Data Prepper as well. All right, I want to touch on a few other things that you can do to help improve the performance. One, I had briefly mentioned that Data Prepper provides routing and filtering concepts. So with this, you can send all the data you want to Data Prepper, and then you can use a pipeline to filter out data you don't want. So for example, you can send some data to S3, or you can just drop data after you've done some analysis on it. We also provide streaming analytics capabilities. So if you have data that has that you can do streaming analytics on, perhaps time series data, you can look at the data and generate aggregations within Data Prepper before you put in the OpenSearch cluster. So for example, you can generate metrics from logs, and you can do that in Data Prepper first so that you reduce the amount of compute that your OpenSearch cluster needs to perform when it does aggregations on those. We also have a rate limiter. We found that this helps some customers who have spiky data. So if you have a lot of data coming in at certain points in time, you might want to limit the data going to your cluster so that you don't overwhelm it. All right, I want to mention a few more things before I wrap up. I had already briefly mentioned it, but I'll be giving a talk tomorrow with Yannick Brand. SAP is using Data Prepper and OpenSearch. And I think we have a really fantastic talk for y'all tomorrow. I'd encourage you to come tomorrow at 11:40. And then I want to mention two other resources. My colleague Krishna Kandaka and I wrote a blog post on how end-to-end acknowledgements work in Data Prepper. You can read that here. We go into some of the internal details that I didn't discuss today. And then I talked about streaming analytics earlier. We have a lot more information about those streaming analytics features. Krishna and I gave a talk at OpenSearchCon in Seattle last fall. And so that's a link to that presentation if you want to go and learn more about those particular features. With that, I'd like to thank you all for coming today. I've really enjoyed being here. And I'm going to be around, so if you have any questions or thoughts, I'm really happy to talk more. So just come and find me. And other than that, I hope you enjoy the rest of your time here.
Thanks, David. That was a nice talk.
Thank you.
So OpenSearch has the concept of ingest pipelines. So how does Data Prepper play along with those?
Yeah, that's a fabulous question, and that actually comes up quite a bit. So ingest pipelines work by running on your OpenSearch cluster, and they can do a lot of the things that we talked about today. So for example, you can mutate data on those. Now, certain use cases, you need to use ingest pipelines. So for example, a lot of the vector embedding type of workflows, we don't have that yet in Data Prepper. And so for those, you would want to use an ingest pipeline. But the main thing about Data Prepper is it's running on different compute. So it's running on a different set of nodes than your OpenSearch cluster. And so you can do all this compute outside the cluster and not have to interfere with the compute or memory of your OpenSearch cluster. And so we have talked to a number of teams who want to use both, actually. So for example, they might want to do some mutation or analytics first, and then use an ingest pipeline for the things that Data Prepper doesn't support.
Hi, two questions actually. First one, is there a difference between Kafka as source and Kafka in the Kafka buffer? And second one is, can Data Prepper be clustered?
Okay, yes, great questions. So that's a good question about the source versus the buffer. So if you use Kafka as a source, you have to define what that data looks like. And the idea is maybe you already have data in Kafka. So you have an existing workflow. You can hook Data Prepper into that so that you don't have to make massive changes. And so now you start pulling from Kafka, and you'll have to do whatever mutations you want on that. The Kafka buffer is really a lot like kind of that diagram I showed earlier where we had split pipelines, but we do it in one. And so with the buffer, Data Prepper itself, it gets the data in whatever form the source decides. And then we kind of normalize the data, just put it into an internal format, put it in a Kafka topic, and then reread it from that. And so the idea there is kind of one of abstraction. So your clients just have to think, OK, I need to write to this HTTP endpoint. And then the HTTP endpoint takes care of storing it to Kafka so that the clients don't have to think about that aspect.
Thank you for the talk, David. So another question which relates to the structured. How can we define the structure of the ingestion, whether it's something we know in advance or we want to impose some structure on the ingestion target?
If I understand what you're asking how do we ensure that the data that goes into OpenSearch is in the right
with
document?
That we select. We know that.
Yeah. So that's where the concept of processors comes in. So for example, I'm going to talk about this more tomorrow in the talk about SAP, but we have the concept of a trace pipeline, and it has processors that will normalize the data to work with the existing OpenSearch observability plugins. But you can also define your own processors, I should say, use the existing processors we have to define mutations that you want to put the data into whatever format works for you.
One more question.
OK.
Thank you for a great talk, David. So my question is, it was mentioned earlier in a previous talk about OpenTelemetry, and you said that it will be somewhat mentioned tomorrow on the talk with SAP. But in general, looking at the data prepper capabilities that you mentioned and some others, and looking at OpenTelemetry's collector component that has also sort of a data processing pipeline with ingesters and receivers and processors and exporters, how does these two open source projects relate in your perspective and in the perspective of OpenSearch as the backend framework?
Yeah, that's a great question. So, for example, we have teams that are out there that have, or I guess what we've seen companies where they have different teams writing their microservices, but then you might have one team that's charged with observability. And so that team will often be the one to put up the data prepper in the front. And then that way, the microservice developers, they'll still use the OpenTelemetry collector or perhaps FluentBit to send the data, but then that cloud observability team will be responsible for normalizing the data and doing whatever mutations. And so you've basically been able to move that, move some of those standardization processors into data prepper. I hope that kind of explains a little bit. Of course, you can also do it even if you're just your own team. And like I mentioned earlier, we do have built-in processors to help get the data ready for OpenTelemetry, the observability plugin within OpenSearch.
Oh, we time.
Okay.
One
more
last question.
Sorry. So from functionality perspective, how is it different to Logstash, for example?
Yeah, so there are, it is a lot like Logstash in the sense that it is a pipeline that runs on different compute. However, Data Prepper is definitely newer, and I actually forgot to answer another question earlier about clustering. So Data Prepper does have a clustering concept so that you can run multiple nodes and even perform aggregations across those multiple nodes. So that's one of the differences. I think in one of the talks I referenced, I also talked about some of the other differences with Logstash. We've definitely seen better performance going into Logstash. And I think we have a slightly different set of processors. And we also have a lot of, well, I guess our sources are maybe a little more opinionated on like how to get the data in. And so from what we've seen, Like with S3, for example, you can use that to use an SQS queue or do a scan.
Thank you, David.
Yes.
A round of
Thank you.
applause, please.